Hi, this is Mrs. Wiederholt, and welcome to my lesson video on solving quadratic equations by graphing. Now let's get started. First, let's do a little review. Now the quadratic equation comes basically in two forms. We have the vertex form and the standard form. Now when your quadratic equation is in standard form, it's written as, you'll see it as f of x equals, you might see it as y equals, and sometimes we'll learn 0 equals, okay? But it would be f of x equals ax squared plus bx plus c. When the equation is in standard form, you can see your axis of symmetry. And remember, if that graph looks something like this, the axis of symmetry is that line that's supposed to cut it in two equal halves. Now, I know my representation is not very good, but this right here would be your axis of symmetry. Okay, so graphically you can find where it is, but if you don't have a graph, you can tell the axis of symmetry because it will be the negative of b divided by 2 times a. And here it is right here. X equals negative b over 2a. Now when looking for the vertex, it is much easier to see the vertex when you are in the vertex form of the equation, because when you have f of x equals a times x minus h plus k, it is the h value and the k value that are your vertex, or that is your vertex, okay? But if you have your equation in standard form, you can also find your vertex. The x-coordinate is actually the axis of symmetry. So you would find out what x equals, and that's your x-coordinate. And whatever x equals, you would plug that in for the x in the standard equation, and that would give you the y, or the f of x term. So even though it is easier to find the vertex when it's in the vertex form, you can find it in the standard form. Now the last thing you can find when your equation is in standard form is the y-intercept, and that would be 0 as the x-coordinate, and then the y-coordinate is whatever your c value is. Now let's do a problem together. We are going to start with the vertex form of an equation, and it's number 1. It is f of x equals x minus 2 squared minus 4. The first thing we are going to do is we're going to convert it from vertex form to standard form. Now we are going to be using some of our Algebra 1 skills because we're going to be multiplying two binomials. Now let's get started here. I'm going to start out, I'm going to go ahead and just say y equals. It's a little easier for me to write on this screen. And remember, x minus 2 squared is simply x minus 2 times x minus 2, which will look like this. Now we can't forget, we have to finish off the equation by subtracting 4. Now, do you remember how to multiply two binomials? I used the FOIL method. That's how I've taught it. I know some of you might have used a box method, but I think the FOIL method is very good for Algebra 2. So we will start out and we're going to say we're going to multiply our first terms. X times x is x squared. Next, we will multiply our outside terms. X times negative 2. Now, do y'all remember the FOIL method? You multiply the first terms, then the outside terms, then the inside terms, and last of all, the last terms. So we multiplied our first terms, x times x, and now we're multiplying the outside terms, x times negative 2, which is negative 2x. Now we're going to multiply the inside terms, which would be negative 2 times x, and that would be negative 2x. And then finally, we will multiply the last terms, which would be negative 2 times negative 2. And that would equal positive 4. So we write plus 4. And then don't forget to bring down that minus 4 at the end of the equation. Now what's left is we need to combine our like terms and we can simplify. So x squared, I don't see any other squared terms, so I'm going to bring that down. Now I can combine negative 2x minus 2x, and that would be negative or minus 4x. And then last of all, I have positive 4 minus 4, and that equals 0. Now for today, I will show the 0, but you don't have to. So we have just converted our vertex form to standard form. Oops, excuse me here. Wanted to put a Y, and then I just want to draw an arrow. This is our standard form right here. Okay? Now to find the vertex of this equation, actually the easiest thing we can do is we can look back to the original vertex form, because our vertex is going to be the h value and the k value. Now remember, when you see x minus 2, that means h is actually a positive 2. So let's go ahead and put that our vertex is positive 2, negative 4. And then I'm going to go down here on the graph and I'm going to do the same thing. I believe it goes right there. Okay? Sorry, my dot's not very good. Now, let's move on. What is the y-intercept? Well, we can look at our standard form for that. Remember, the y-intercept is the c value, or in other words, you would put it like this: 0 and then the c value. And it just so happens our c value is 0. So we could go ahead and plot a point right there on the y-intercept. Now at this point, we could jump on down and let's do the axis of symmetry. Because remember, the axis of symmetry is the x-coordinate of your vertex, because it's where this parabola is going to be cut in 2 equal halves. And so let's go ahead and write that our axis of symmetry is x equals 2. Before we find our x-intercepts, our roots or our zeros, remember those terms are used interchangeably. Let's go ahead and plot the points to the rest of our parabola here. Now, because there's no a value, I know that this is going to be like like the parent function, y equals x squared. So I know that when x is 1, I'm going to move to the right 1 and up 1. When x is negative 1, that means negative 1 squared is still positive 1, so I'm moving left 1, up 1. And then I can move to the right 2, and I can move up 4. And then I can move to the right 3, and I can move up 9. So let's see, 4, 5, 6, 7, 8, 9. And that means the same here. If you go over to the left 2, you go up 4, which puts you at 0, 0. And if you go to the left 3, you will also go up 9, which puts you right there. So now I'm going to draw, and again, not very good, but you can see where it's supposed to be. And now we can find our x-intercepts. Now, if what I just did to plot those points is a little confusing, remember you can always enter either equation, either the standard form or the vertex form, into the y equals of your calculator, and you can look at the table to find your points to graph. Now, it is very easy for us to look at this graph and see what our x-intercepts are. I have one here at 0, 0, and I have another one at 4, 0. So how we would write that is our x-intercept, you would say, is 0, 0, write it as an ordered pair, and we have 4, 0. Now that we have our x-intercepts, we know what our roots and our zeros are. The roots would be x equals 0 and x equals 4. And the same thing for our zeros, x equals 0 and x equals 4. Now, I don't know if I've talked to you about this before, but x-intercept, roots, zeros, and solutions, all 4 of those terms are used interchangeably, meaning if they ask you to find the roots, they're asking you to find the x-intercepts. If they ask you to find the zeros, they're asking you to find the x-intercepts. And also, if they're asking you for the solutions to this graph, they're asking you for the x-intercept. So you just need to know that all four of those terms are used interchangeably. Now the final thing that we're going to do on this example is we are going to find f of -1. All we're saying here is what would y equal if x is -1. So let's use our equation x minus 2 squared minus 4. And we're substituting the -1 in for the x. So it's going to look like this. We have, instead of x minus 2, it's -1 minus 2 squared minus 4. Well, -1 minus 2 is -3. And -3 squared is 9. And 9 minus 4 is 5. So what we're saying, when when x is -1, y would be 5. So let's just look at that. If I go to my graph and I move to the left 1, that's -1, look what happens. Up, 2, 3, 4, 5. Y is 5. Now in my next lesson video, I'm going to be showing you how to find solutions using your graphing calculator. So I hope this video has helped you learn how to solve quadratic equations by graphing, and I look forward to working with you again. Bye-bye.